What's up, everybody? I'm going to show you how to do the radius of convergence. And by doing this, we are going to use the ratio test. So here's the problem. Took me a long time to get that E right. Alright, so if you remember the ratio test, this is the format for that. And remember that this right here is a sub n. So let's start working it out. And hopefully my cup doesn't get in the way. All right. So that's what it is, all written out, no tricks or anything. But now we can start simplifying. I'm going to write it as a multiplication instead of a division by flipping this fraction right here. So this is just x to the n plus 2. And then I'm just going to copy this down. Then times the opposite. Or not the opposite, the reciprocal. Alright, so now we can start canceling some stuff. So this is the same as this, but this is just another 4. And so that's 4. And then this is pretty much the same thing, x to the n plus 1, but there's another 1 left over, so that's just a plus 1, which means there's another x here. So that turns into x over 4. And this transfers over, and that transfers over. Sweet. So, oh, I forgot the limit. Alright, so I'm going to move my cup slightly. Boom. Alright. So now, if you take the limit as n approaches infinity of xn to the 4 over 4n plus 1, this 4 is going to end up going right there eventually, and then if you expand this out all the way, none of the other stuff is going to matter really, because the limit as n approaches infinity only takes into account the highest exponents of n. So it will eventually turn into x over 4, because these exponents are the same, so it only takes into account these coefficients. These absolute values have not disappeared yet. So the ratio test tells us that if this number is less than 1, then it converges. So the radius of convergence is what x values would you put into the original function, which is, remember that right there, that will make it converge. So since this is an absolute value, or let's not go there yet. This is the same as that. Okay? Because 4 is positive no matter what. That's not a variable that's changing negative at any point. So, get x by itself. And this turns into, as long as the absolute value of x is less than 4, then the original summation will converge. So this is the radius of convergence. And then another way to write that is called the interval of convergence. Which is just the same thing but written out without the absolute value. And there you have it.